Hello everyone, and welcome to today's webinar. I'm a virtual avatar in Developers Short. I hope you're all doing well and ready to learn. Before we get started, I just wanted to take a moment to invite you to become a member of the Great Devs. As a member of the Developers Short community, you'll have access to our job opportunities, activities, and future webinars. You can join us by responding to our invitation email or completing the form on our website. Also, a recording of this webinar will be on our LinkedIn page. Without further ado, let's dive into today's topic. Please give a warm welcome to our speaker.
Thank you all. I'm Evangelia, and I'm happy to be with you today to share some knowledge regarding where the UI is heading with the help of AI. Topic of today's how we can go from reactive to predictive user interfaces. We will see what is reactive interfaces, the ones that we are used so far today, and how they will become predictive with AI. Predictive means they will become more intelligent and they can predict how the user will behave. So they will make some suggestions before the user actually makes the suggestions. Okay, currently I am the founder and the CTO of Philomath Academy, and Philomath Academy is a boutique academy which aims to upskill front-end engineers of all levels, mid engineers to become really seniors, juniors to become mid engineers, and to help you find amazing jobs in top-tier employers. Just a few words about me. I don't want to talk about me all the time. I have worked almost 20 years in the tech industry, mostly as a software engineer, with my focus as a front-end engineer. My previous employer before founding my own company was Elastic. I was on the Elastic Cloud. Before, I have been in Switzerland for 10 years, where I worked in an AI startup, machine learning at Technopark Zurich. I have worked for Google in the Google Assistant department for a while, many others as well, but they were worthwhile mentioning. I have even worked at the ETH, which is the Federal Institute of Technology in Switzerland, as a mobile developer, where we have been building mobile apps for NATO training school. And before that, my career back in London was still in tech industry, but in a different discipline, which was semantic web and linked data engineer. We were developing knowledge graphs, ontologies for medical education. Okay, let's go to the to the most important stuff of today. So this is the agenda. We will have a look on what actually means reactive interfaces versus the future predictive ones. Then we will have a live demo, a 4 or 5 minutes live demo on what I have built. I have built an interface that looks like ChatGPT, so we will see it together, a deep tech dive, how this have been implemented technically and visually, what are the smart behaviors. We will see in chapter 3, 4, and 5 all the technicalities behind that. And then we will conclude what does this mean in general for the product designers, what the modern UIs will look like, or what type of characteristics they will contain. We will touch a few of these stuff, like 3 techniques today. We won't cover all the future product design based on AI. We will see 3 techniques altogether. So, what is the AI weight problem? Most of you have been using the last year ChatGPT, Claude, Perplexity, all these LLMs. And we have noticed that these systems take a while until they respond back to us, because they have to think, to compute, to make some more heavy computations, because they are searching, they trained data on the web. Sometimes they need to make summaries, they need to make different analysis. What impact does it have to us as users? We have noticed that sometimes we wait for a couple of milliseconds, 10 milliseconds in ChatGPT. So we wait a lot. Even we can activate the thinking mode in ChatGPT, if you remember, so that we see the LLM, how it thinks until it responds back to us. So this new extra time that is needed in modern AI assistants creates some form of anxiety to us, because we have to wait more comparable to the standard one. Sometimes we might even feel like abandon the page and moving to another way of finding information. So it's like we might lose trust, especially sometimes when we end up on infinite results and the same results on LLM. So this is a different experience comparable to the experience that we used to have so far. The reactive paradigm is what we have so far, what it is. We, as users, click, for example, on buttons on an interface, and then based on, let's assume we are fetching data by clicking on the button, and then the button, what it does, it executes a post request, it returns back a JSON, and until we get back the list of data through the JSON, we are seeing a spinner, the standard loading spinner that most of you have implemented in your applications. And then we see the results. This means that the system is reacting to our actions. We are clicking on buttons, we are fetching data, and we see spinners until the data is ready. This is what we all know so far. Just a note on that. Back on my early years of software engineering, one of my mentors told me, never forget, Evangelia, to visualize to the users a feedback, what's happening. That because we don't want the screens to show frozen. I remember many times, in production, many engineers are busy and they forget to implement the loading spinners. They just do the submit and error in the end. What's happening in the between is not often visualized. You always need to do it, even if you're in your so far experiences without the AI. Loading spinners always show to the user what is happening. The difference now in the new AI, so we used to have so far 3 states actually: the loading state, the success state, and the error state. 3 states. And roughly this is how it was implemented, for example, in React. In React, without the suspense in the most modern way, let's say we used to keep track of the data, which is the raw data, the loading state, and the error state. And on the success or error case of the fallback, we were setting respectively either the error or the loading. And below, we were loading conditionally either the loading state, if the data were arriving, the data case, or the error case. So 3 distinct states. However, in AI systems, this won't work because it takes more time to fetch data back to us because they compute, they think, they do more heavy computations. So just a loading spinner will feel like it's frozen to us. That's why users don't know if the system is working or not. We need to find different ways of visualizing to the user what is happening in AI systems, not in regular click buttons that they just fetch data. So how our UIs are evolving? They are evolving to the Thinking UI model, or we can call it Predictive UI model. People that they are product designers or UI UXers all these years, they do a lot of research and they will let us know, exactly about, in a more mature state, how this will look like. But this is an advanced experiment that I'm running through as well. So the Thinking UI model, we click a button, we see the LLM, how it thinks before it finishes the computation and get us back the answer. Previously, we would see just a spinner. Now we can see a streaming of thoughts. We can see in detail, in a transparent way, how the LLM is thinking. And while previously it was like a black box. And sometimes we can add even more smart behaviors. Like once we get the answer, we can even prefetch some questions that we think the user might ask, and so forth. We will see all together in a bit. Sorry for this. So the benefit of this Thinking UI model is that the user might feel they are more engaged because the streaming process that shows the thinking notifies them about what is happening. So they have a feeling like the system is responding to them, is notifying them. They are not left in the wild. So these are some examples of the modern platforms that they're using this Thinking UI pattern. Most of you, I guess, you have seen it. If you haven't seen it, you need to notice that there is a button in ChatGPT and in other LLMs. You can activate the deep thinking mode, so you can see the streaming process. Why this matters? Before we move on to the technicalities, it gives trust. Users understand what is happening. Engagements. Active watching versus passive waiting. There is a perceived sense of improved performance because we see streaming of thoughts visualized, and it gives the feeling that it's faster. Debuggability means that even if it fails the LLM to respond to us, even if it stops during the thinking process. We can see exactly during which thought it stopped, for example. So it will help us on the debugging as well. And transparency, we know what is happening under the hood, roughly. Okay, let's see now a live demo to see the UIs that have been built. Okay, this is a chat AI assistant. At the first glance, look like ChatGPT, which means this is real AI today. It's not mocking. I'm using a real AI model, which is called Llama 3.2. And it's called by a tool called Ollama. Ollama is a tool, and Llama 3.2 is the model from Meta, and it's running on the browser. No internet is needed on this one, no outside of the browser, local storage. So I want you to keep that in mind, that there are models that they can run purely on the browser. There are pros and cons with these models. So you need to see if your use case is suitable for using these kind of models. Sometimes these models are lighter comparable to Anthropic models or Claude or Perplexity, but they can do the job really well because it stays on the browser, it doesn't go through the internet, and it's more secure. That was the initial reason that LLMs in the browser were invented. So what I'm doing, I'm activating the demo. You will see I opened also the network tab, and I'm asking a question. Before I ask the question, I pause it a bit to show you that besides typing a question on this input field, I have a suggested questions box as well. This suggested questions box, you will see, I loaded it initially with some predefined questions. As we start interacting and asking questions to our assistant, these suggested questions will be adapting to our questions, to our conversation history, and you will see later on that they will adjust to our topic. If you ask them something, I will ask them later on about the Greek islands. I come from Greece. So you will see that the recommended questions will be around Greek islands. So we will see also, this is part of predictive UI. We are helping the user, we're giving to the user a pool of questions that we predict the user might want to ask. So this is also a second predictive technique besides the streaming that we will see now. So I'm asking the question, what's the difference between React and Vue? So the moment I clicked ask, I'm asking really the Llama 3.2 model. You can see on the right, the endpoint. I'm using Next.js, and we are calling Next.js root. We will see the code later on. The socket, this socket endpoint is in the Next.js API root. So you can see the thinking box. It shows gradually, it streaming the thought process. So the thoughts, the thinking phase stopped. Below on the green area, the LLM told us, okay, I finished with my thinking, I'm ready with the answer now. So we are also visualizing the answer gradually as well. How does this differ from the reactive interfaces that we had so far? In the reactive interfaces, we were showing all the answer at once. We were showing usually a spinner, and once the data arrived from the backend, we were showing the full box. While now we saw gradually every single sentence. This is predictive and more AI friendly. So I want you to see the answer finished is ready. So when the answer has finished, I'm triggering on the network tab here a second endpoint, which is another backend API which I implemented, the suggestions API. This is another smart technique. So I'm giving you today inspirations on what smart behaviors we can add to the browser. Suggestions, what it is. Based on the answer, now the system keeps tracks of what are my interests. Like I asked about the difference between React and Vue. So it will recommend me questions similar to React and Vue. Question: if the Llama fails to be connected for any reason, we need to have also a fallback case. On purpose on the demo, that specific request, I left it, it didn't work because the internet was low, it was lost the connection. So I implemented pattern matching. So if for any reason the OLAMA doesn't return the result for that specific question, it works in most of them. But if it doesn't work, we need to load from a fallback case. Pattern matching means we have some local answers and we match these answers with a question to see where it fits. So it recommended that, again, the initial ones. Later on, the other question, you will see it's working. So I left both cases so that you see the pattern matching. So this is how you see on the browser how the events are streamed. Usually, so far, we have regular JSONs. You send JSONs to the front end, and that's all. In that specific case, we don't send a static JSON once, and that's all. We're streaming events over time, gradually, sentences, words. So you can see on your event stream tab, usually you don't touch this stream tab. Usually we go to the response or to the payload. Here, we are streaming from the backend data. The suggestions, this is the suggestions calls. I want you to see here, it shows source pattern matching. I implemented this response to know if it worked from the local or from the real OLAMA. In that case, it goes from the pattern matching. And the third smart technique that I want to show you, what I implemented, out of these 5 recommended questions, I'm preloading the answers for the top 2, because we assume that the user might want to click the first 2. In real machine learning systems, the machine learning engineers will find a real algorithm to decide which of these answers are the most probable the user to click. I arbitrarily assume that he will click on the first 2. So this socket and the second socket are the responses, are the preloaded answers of the first 2 questions you will see. So the socket endpoint is being called. The very first that you can see here is once we click the ask button, which loaded the answer, then is the suggestions, which is the purple box, and the suggestions preloaded also. The suggestion is just like 4 questions, and the 2 sockets sequentially after the suggestions are the content of the first 2 answers. This is smart, this is predictive, because the user didn't ask for it. We are predicting that the user might want it, and we will see the benefits of that in a bit. So, I want you to see also in console log how we are debugging this. I'm just showing you also in console log the prefetched, the 2 prefetched questions and their data. How long does it take is the second question to become job ready. And now I will make and I clicked I click the second question. You will see. I'm clicking now in a bit the first question I'm clicking, okay. And the first question is one of the 2 that was preloaded from the cache. So do you see here the hint loaded from cache? So the filling is instant. The user doesn't need to wait because we predicted that he will click on this question later on. So that was a smart behavior. Now that he clicked on that, our suggestions this time also worked. See, the suggestions this time worked, and it shows source from OLAMA. And it shows now questions regarding the differences between the frameworks, not the generic tech ones. And it preloads again the first top 2 of these ones. What are some popular front-end frameworks, and how do I choose between full stack? So I'm showing you here the 2 preloaded questions of the second round of suggested questions. And now so we will also ask something completely different to the chat. Now we'll ask a completely different question. What are the best Greek islands, for example? We click ask. It will ask again the model, the LLM. It is thinking. We visualize the thinking. We visualize the answering as well below. And then once it finishes the answer, it finishes the thinking, it finishes the answer. And when it finishes the answer, it also recommends suggestions based on these interactions. So because we asked about Greek islands, the Ollama is returning back to us 5 suggested questions around the Greek islands. Indeed, I want you to see what are some hidden gems on Santorini Island? How does one get around Santorini? So it worked, the recommendations. Okay. And again, you see after every suggestions, you see the first 2 that we preload the answers as well. So if we click in one of the top 2 questions, we will see instantly the answer. If we click on the third one, it needs to load the answer from the LLM. All right. Yeah, if we click the second question, it's loaded from cache because it was preloaded just a few minutes before. So this gives a feeling to us that it's a fast AI and it is a smart AI that predicts what we want. So it's a demo, it's not the real algorithm, but it's real AI. Let's say we assume the top 2. This assumption in real machine learning projects might be a bit more complicated. Okay, that was the demo. And let's move on to the technicalities. Let's do a deep dive. I want you to see the overall architectures from the data layer to backend to frontend. Although I'm a frontend engineer, all of us, we are full stack engineers, T-shaped engineers. We are just expert in one of them, but we know the full stack and we can implement it. So I'm using the Llama 3.2 model from Ollama tool. And on the backend, I'm using a Next.js API route, and I'm using the readable stream API in Next.js. We will see how it's being used. As a fallback mechanism, in case the Ollama for any reason might not work for one of the attempts, we do pattern matching, which is locally, we have some local JSON data, which we compare our answer with this local JSON data. And then we send server-sent events. I want you to note down this keyword. This is the technologies that we send servers and events is like an alternative of WebSockets if you have used WebSockets. And the browser consumes the servers and events with the event source API, and we will see what impact does this have to the React state actually. It become a bit more complicated. So tech stack, I'm listing here so that you see the names of the technology. We use the readable streams API on the Next.js. It's standard for creating servers and events. The stream API is emitting streaming data from the backend to front end. It's one-way communication. It's not two-way. In polling, in the next slide, this one, servers and events is this communication between the readable streams API and the front end. In the front end, we use the event source API to listen and wait from the streams that this first API is sending. Ollama, the tool that can run different models. You can even run Gemma models. They are from Google. This is from Meta, and whatever other models you have experienced that Ollama can run. And it runs offline. No API is needed. It's real AI streaming. You don't need to pay as well, so you can really start experimenting with this tool from today. And pattern matching is this technique of smart fallback system. Why we use servers and events and not WebSockets or polling? Polling is what we used to do over the last 10, 15 years. What is polling? We are fetching data. We are asking the backend, hey, are you ready? Do you have this data to give it to me? The client is initiating contact and ask the backend, keeps polling every time. No, we don't want that. WebSockets is WebSockets, the backend initiates communication with the front end, but it differs with servers and events in the sense that in servers and events, the connection auto closes as well. It doesn't stay open infinite, and it's very suitable for serverless infrastructures as well. So automatic reconnection comparable to WebSockets. We don't want a constant HTTP connection to be open all the time, and serverless technologies. So your way to go with streaming is SSE. So an servers and event format looks like this. This is how we send data from the backend to the front end. Consequently, we have a data property, and I specified different types of phases. the model is thinking initially. So I'm notifying the browser, the client, hey, what I'm sending you now is still thinking mode. So type of data, type of stream data, thinking. Thoughts is exactly all the sentences, thoughts of the LLM. A second phase is the answering phase. You remember we had the thinking box. Once the LLM finished the thought and was ready to deliver to us the answer, the data that are being streamed can have the type streaming or answering. It's up to us how we call it. And then once the answer is also complete, we can send a signal from the backend to the frontend, like we are complete, no more extra sentences to be streamed for the answer. And here at the client level on the front end, we are using it like it's like a subscriber, like an event listener. We use the event source API on message, and then on the event handler, what you see here on the event is the data that we sent here exactly. Let's go the deep dive. This is the API socket root implementation. This is the endpoint that is being called when we click ask. Okay, it makes the real question to the LLM. How we do it? You can see here that first of all, we are using the Olama tool by using the chat method. This is how we set up the model. Here we specify the question. I have the question in a separate slide so that you see it better. This is how the question could look like, the prompt to Olama. You are a helpful AI assistant that shows its reasoning process. When answering questions, first show your thinking steps, then provide the answer. Format your response exactly like this, thinking. First, think the different steps we want roughly, the different phases, and then continue as needed. Answer your detailed answer here. So this is the answer. And here you can see the different phases that the LLM could be. If we are in thinking section, we are sending events to the front end that are of type think. You remember before we saw here type thinking. The type thinking is exactly these NQ data type thinking, and this is the thoughts that it received from here, from the chunk. I'm giving you a screenshot of the full system to be easier for the presentation. Okay, not all of it. They could be too chaotic. If we are in answering mode, we are sending type streaming, or we can name it answering. It's up to us. What I presume and I imagine for the future, like all of this will be somehow standardized, and we might have some predefined phases with proper names. And we send the complete here. And for any reason, when the answer has been completed, and for any reason, if the Olama didn't work, which did on my demo on the very first case, which I left on purpose, we do pattern matching. So always remember to have fallback for your production ready codes. Yeah. Let's go to when the answer completes. So when we send the complete now to the front end, what happened in the demo? When we finish the answer, we also trigger the suggestions because we fill our conversation history with new data because we finished the answer. So now it's like, oops, we gathered one more information about this user, what he asked, what answer he got. So maybe we can improve the recommendations to him. So once we send the complete to the front end, the front end we are here on a React component. Sorry, this is a mistake. We are not on API Rootkit here. This is a front-end component that is listening on message this complete. This is the complete that we send here, the complete. So the front-end component here listens to this complete. We will see this later. It triggers a dispatch an event. We use useReducer. That oops, we finish the completion, and then later on it updates the suggestions, generates new suggestions, and the generate new suggestions under the hood contains the call to the API suggestions, the second endpoint that you saw that is being triggered after we finish an answer on the screen. So the API suggestion is this page, and you can see this is the backend. We went to backend code again to see how the suggestions is implemented. We are taking from the front end previous question, previous answer, conversation history. See, on the front end here, we fetch API suggestions and we pass in the body previous question, previous answer, conversation history. We fetch them here. We have access to them. This is a post in Next.js root. And we write a prompt, another prompt for the suggestions. This is a prompt for the suggestions and not a prompt for the LLM to retrieve an answer. So based on this conversation, generate 4 relevant follow-up questions. Previous question is this, previous answers is that. Rely on a JSON array. And here I'm telling him, like, let's assume that the answer that you give for every question has a specific confidence. How confident you are that this answer the user will like. This one I'm hard coding for the purposes of the demo. This confidence score is something that in true machine learning, people will compute it with, I don't know, with need to train some models to find dynamically these values, specify this property. So we are assuming that's the first question has the higher confidence score, the second question has the second confidence score. And this is the response, Olama generate. We use this model, we use this prompt that we specified above. We don't want streaming here on the suggestions. We don't want streaming suggestions. We want them just the purple box. Streaming want on the thinking and on the answering box, not on the suggestions box. Okay. So non-streaming for the suggestions. It's a post endpoint, and always we have a fallback pattern just in case the connection something doesn't work. Although Olama doesn't work with internet, but by connection I mean the connection to the model locally. Also, this might fail, it might be slow for any reason. Any port might be not available. This is going to be connection, not internet connection, because it works locally. All right, let's go to the React impact on this. Okay, we said before that in the reactive UIs, we have 3 states, right? Loading state, success state, and error state. Why those 3? This is the asynchronicity stage on the browser. Asynchronicity means we initiate an action always, and we don't know how long it will take until we fetch data, we communicate over the network. So that's why until we wait to hear if it's success or not, we call it loading state. I used to call it ink status. It's the end of loading, parsing the ing. That was my metaphor of saying the ink status is. So, but in modern AI UIs, we can have more than those 3 initial states as we show. We can have an idle state, which is the very, very initial state before we start clicking on any ask button, for example. Then we can have a connecting state, which is the time that is needed to be connected to the model, to the tool that is using the models. Then could be the thinking phase. Then could be the streaming phase or answering. The complete phase, the error phase. So it's more granular. The states are more granular. Let's jump into this is an overview of how the React component would look like at a very high level. This is a canvas component. We have the state, and in the state, you remember we had an input field, we have recommendations, we have thinking, we had answering. All of these data, states, transitions, we store them on these AI states, and we are using the useReducer and not the useState. useState is the more common hook that we all use for more plain states like numbers, strings, or JSONs. When do we use the useReducer? When the local state, we are talking about local state, is more complicated, complex. Many of you might have used Redux or Redux Toolkit. This is where you have seen the reducers. In global state managers, we are using reducers because the states are more complicated. Similarly, the useReducer hook is being used to handle complexity in local state of the component. We will see. Suggestions, this is part of our state, and conversation history, which we need to keep track of it to make suggestions. We have some custom hooks. I guess many of you are familiar with custom hooks, many not, depending on your level, but custom hooks are really a nice design pattern in React in order to do separation of concerns and abstract business logic outside the main component. We don't want to make it too messy and too heavy, too busy with lots of logic. Here you will see how we are listening, registering to the events that the backend is emitting. This is the event source API that we mentioned of the initial tech stack that will be used on the front end. This is part of its syntax on message thinking. Here I wrote just the abbreviations of the real handlers in order to fit all on one screen so that you have an overview of the component architecture. So here we have the listeners. What will happen when we receive on thinking data? We update the thinking box. What will happen when we receive streaming data or answering? We update the green box on the bottom. What will happen when we receive the complete message? We will trigger the suggestions to update the suggestions. And this is the UI. We have the questions input on top, thinkings panel, the thoughts, the answer panel, and the suggested questions. Let's deep dive to one of these hooks. Then let's go to the use server send events, which is the one where you actually see how we use in the client the event source API. This is how we initialize it, new event source API. Sorry. We need to keep track of the connected is connected, the error states. We need to initialize it with the useRef custom hook here. And here we write a generic code here. This on message is a generic code so that it reads the handler that will pass to it on the component of the outside. So this is the user server send events. And why we do it in a custom hook? The benefits are encapsulation with hooks, reusability in other components, error handling is better centralized. And here you can see here how we use these use server send events. This is the definition of the use server send events hook. And here on the component, on the initial, on the canvas component, you can see we use this use server send events, which exposes all these different internal details, the connect, disconnect, on message, disconnected error. And the on message, we grab the on message from this hook, and this is how we implement the thinking process. Regarding, I will go first to the useReducer. We mentioned before that useReducer is being used in React when the local state management is a bit complicated. By complicated, I mean we don't need just to remove an item from a list. How would we remove an item from a list with standard use states? We apply the shallow copy, the rest operator, or we do some filter and we remove the item with just a filter operation. Here, we have an extra layer in our state, which is we have different action types before we decide what mutation to do to our state. We have this thinking phase, and based on the action, we go ahead and we implement one of these cases. In regular state management, we straight away do one of these cases, but in this case, we have also this action layer, which based on the action layer, our mutation is different. So when we have the action, we are adding actually visually to the thoughts component the new sentences that are coming from the backend. The same for the thinking box. This reducer is the moment that is updating the state, and we visualize the extra lines that are being shown on the gray area. On the complete, we update that is thinking is false, is complete is true, final answer is that. And this is how it's being initialized. We showed it before on the first page. The con state, this part, useReducer, AI reducer. AI state, it was called on the previous slide. Okay, another important hook that you will need in such smart AI interfaces is the useTransition. I don't know if you have used it. It's relatively new. And the useTransition hook from React is being used when we want to update the state on the background and not to interrupt the very emergent processes. For example, when we start typing on a box or clicking on buttons, these are, let's say, high critical actions. We don't want to block, to froze the screen, and the user shouldn't be able to type on the screen. That's why, if you noticed, we were loading the thinking process, so we were updating the thinking box. But if you wanted to type on the input field, still you could type, because we are using start transition to update the state. Start transition means on the background, update it, but don't block the user. If you start typing a new question while it still thinks, the start transition updates the thinking on the background. If you finish your question and the first degree, the most important actions are free, let's say you don't block anything, then the start transition takes a priority. If, let's say, the floor is open, no one is there on the high priority actions. If someone jumps again and start typing, the start transition goes on the back. So it does this switching between, okay, I can work on the background while you user type something, but when user stops typing something, I can also on the foreground continue traversing the streams. This is what, and we can see the syntax here. Start transition is being used for that, and inside we use the dispatch, which is related with the useReducer. We dispatch the action that we want to be executed, to be passed to the reducer, to decide what change to do to the state. It is an add thought, so it will go and update the add thoughts, for example, case. All right. So let's recap the reactive dive key takeaways. Custom hooks encapsulate complex logic, servers and events. Prefetching, we will see also the prefetching. We show a few of them. I go back again to connect the dots. We show here on the component architecture the use servers and events. We show together the AI state with a useReducer. And we show the suggestions before on the previous backend when we were triggering from the answer. And custom hooks, we will see the use prefetch on the next section. All right. Start useReducer manages related state atomically. Start transition keeps UI responsive during streaming. The responsive means the user can continue search new questions or click buttons while the streaming is being shown on the green or gray boxes. Use memo, I had some other slides, but I didn't want to overload you. And we use the standard use memo, use callback when it's needed, because now I have the React compiler as well, to optimize the re-renders. But the focus I want to be now on the useReducer and use transition and the new tech stack about streaming. Warning, don't use start transition for the urgent updates. Again, use transition is for background tasks, like showing the answer, showing the thinking process. All right, let's do one more last deep dive regarding the last two techniques. So far, we show the technicalities of the streaming of the thoughts, how the backend is sending the streams, either via thinking or streaming or complete status. We saw on the front end how on the on-message handler it can read it. We saw a little bit how the React state can be handled. And let's see the last two techniques, which is the prefetching and the caching. What is the prefetching? We showed on the demo. Prefetching, if you remember, is the prefetching of the answers of the first two recommended questions. So we have a box with 5 recommendations, and we were also prefetching the answers of the 2 of them, and then they were cached. So the goal, we make suggested questions, clicks feel very instant. That's why when we're clicking on one of the first 2 recommended questions, we could show the loaded from cache actually. And actually, the goal is to anticipate, that's the word, anticipatory design is all that is called. We anticipate what user might click next. The solution. The solution is when suggestions appear, we automatically prefetch answers for top 2 questions by confidence score. We hard-coded the confidence score for the sake of the demo. We also arbitrarily thought the first 2 are the most important ones. Prefetch load answers in the background. Let me not repeat it again. When user takes a prefetch question, it fails instant result. If we clicked on 3 or 4, it would be normal wait. It has to reload it because this was not preloaded. So this is the prefetching technique. We can see now the code, the implementation of the prefetching, which is the use prefetch hook. We use the cache ref as an object to store the answers. You can see here we are making for the suggestions. We're making again the socket. We're calling the socket endpoint, which is the one that makes the question to the Olama about the specific question. So we are preloading the question, making to the LM, and we are adding it on the cache actually on our cache. We are adding the specific questions actually. 80, something regarding the prefetching based on some user psychology. User clicks top suggestions mostly, and it auto-caches the first 2 answers. So let's see. This is the psychology that I mentioned here. If we wait again after clicking a suggestion, it could be a bad UX. That's why we don't want that. We want to preload the results. Technical benefits, perceived performance, instant. But there are trade-offs in everything. It uses more bandwidth because we make these extra calls to prefetch data. So we need to be. So when we become large scale in production, this is where we need to make some smart decisions on okay, how much should we prefetch in order not to be on the to be a drawback for our performance. It uses more server connections and it might be bad impact on the battery of mobile. Let's go to the last predictive technique, which is the caching. The caching is actually is tied together on the code with the prefetching. Prefetching is calling the answer for the first 2 questions, and caching is caching it as well, not only calling it, caching it as well. So what the problem here, user has to ask some questions twice and has to wait for full response again. The solution, we cache complete responses and returns instantly. In our Canvas component, when we click on any of the recommended 4 questions, when we click in any of them, the handle ask question method is executed, and it checks internally if the question that we asked is part of our cache that we implemented or not. So if it's part of the cache, it dispatches the load from cache event and it loads it from the cache. Otherwise, if it's the 3rd or 4th recommended question, it does a connection to the socket again and makes a real question to the Llama model again, if it's not cached. So this is the part of the logic where you can see when the caching is loaded. All right. And let's go to the last section, which is the product design implication. Just to summarize it from the product design perspective, already you get a quite good grasp about it. User psychology, transparency builds trust. Research shows that seeing progress reduces perceived wait time by 30-40%. Users trust systems they understand. Understand is an overrated word. It's not like we understand completely what is happening, but at least we have a better feeling of what's happening behind the black box, the curtains. Progressive disclosure creates engagement, a fancy word, but it is the technical word. Progressive disclosure. Progressively, we're showing the streams actually. And working indicators reduce abandonment. So it's around all these concepts. Now, the thinking UI pattern transforms waiting into watching. creates narrative around computation, and builds confidence in the system. So now this is some other UI, let's say UX techniques on this modern anticipatory design. I'm not a UXer, but I love UX a lot. As a front-end engineer, we are on the crossroad between back and front, everything actually. So I love product and users. So I explored a few more techniques that will have an impact on modern UX. So one of them is, let's say, interoperability, which means that the user should be able to stop the LLM if it keeps, thinking, or by accident we clicked ask something and we didn't want to ask it. So we need to have the option of stopping that. If you remember, there was also in ChatGPT there is the stop. It takes the form of a square icon. I think the button on the chat on ChatGPT. So it's exactly part of this interoperability, like to give the option to the users to real time to interact and stop it, see how it's thinking. So it's new new UI controls, I would call them. So interoperability is one of them. Cancellation is related. Allow users to stop. Yeah, there's slightly related. Clear visual feedback when cancelled. And visibility control is what we have seen so far with the thinking process. And I guess there could be more stuff, like, for example, in some other modern chat interfaces, they have also on the chat area, also we have buttons to upload lots of files because we want to improve the context of our question. The more files we add, even when we implement vector databases and all these RAG implementations, these are all new UI controls. In this new AI world, we need to make our, let's say, conversation experience with the LLM ready with all the tools that we will need to use them. When not to use this pattern, when we have fast operations and we know that it will be instantly replied in standard, so far when we retrieve a list of data, we don't need so much streaming and so much details. We will stick back to our reactive pattern. Mobile with limited space, consider and condensed version. And where simplicity is the goal, we don't want that. So I want us to be aware of what exists technically, what are the benefits, and then you need to make the conclusion and judgment. Does it suit your project, your needs? Technically, okay, it's fun, it's wow to explore it. And then the next phase is to find its applicability. Key takeaways of the presentation. UIs are evolving from reactive to transparent predictive. 3 predictive techniques we saw together: streaming, real-time progressive disclosure with servers and events, prefetching, anticipatory loading of likely actions, caching, instant recall for repeated queries. State management needs to go beyond loading states. We show 5 other states, like thinking, complete, and streaming. Product design must embrace progressive disclosure, and not only, actually. And these patterns work with any backends, simulated APIs, local models. So I did it with Next.js and the local model of LAMP 3.2. I want to deeply thank you for today. I will have a look to the chat in a bit. I couldn't look on the other screen. This is if you want to reach out to me, send me an email or access my platform. And very soon, guys, in a couple of weeks, months, I don't know, I'm preparing a course about data structures on front end with real world examples, and it will improve you how you think architecturally, because so far all the courses around DSAs are very theoretic and mostly on backend regarding how to reverse a linked list. And so far, this one is going to be based on my experience in the industry with real world examples, how we become better engineers on data structures also on the browser. If you want, you can join my newsletter also for free content as well. And if you need anything, feel free to reach out to me. All right, I'm ready for questions. Yeah, we are almost on time. Yeah, okay, cool. Public, I see, don't say thank you to the AI, for example. In this case, it is feasible to ask more questions in advance to reduce. Guys, I'm reading the question. No. I cannot see everything. Let me see. I see a sentence that starts with, don't say, don't say thank you to the AI, for example. In this case, is it feasible to ask more questions in advance to reduce the response latency for the user? What's the question? Can you repeat it again? Yes. The AI thinking process has an energy consumption issue. Indeed, that's the drawbacks, where its response consumes a lot of electricity. Yeah. That's why we need to find the sweet spot between how much of it we predict is important for our users, and in order not to overdo it. This is a joke, mostly, as I got it. But I think with smart machine learning, it's worth prefetching stuff, finding this sweet spot. But this one is also local LLM, so it doesn't go also through the internet. But yeah, I see what you mean. Yeah, more electricity in our computer, more power. There is the other side of things always. Yeah. But everything has also pros. So for the sake of fast responsiveness and this feeling of customization, like the interface is taking care about you, I think it's worth it. Yeah.
Our webinar has come to an end. I'd like to extend a big thank you to everyone for participating, and a special thank you to the speaker for a captivating topic. It was a pleasure having you all here today. Have a great rest of your day.